We don't need to find the second derivative unless, because that could normally this is potentially, I should say, more difficult than anything else. But if you want to use a second derivative test, it's a different story. That's fine. Okay. So I'll start with the table. I only need f prime and f. And only between -2 and 1. So I will start by determining f prime, which is 1 over x squared plus 3x plus 9 times 2x plus 3, the inner function prime. Critical numbers can come from two sources, as we know, either from f prime of x being 0 or f prime of x being undefined, where the function is defined. But this is never 0. How do I know? Because this is part of the difference of cubes. That's one thing. So x cubed minus 27. So this is x minus 3 and x squared plus 3x plus 9. And I know that this will never be 0. But you can say, I don't remember that. That's fine. If you don't remember that, that's okay. You just write x squared plus 3x plus 9 equals 0. You use the quadratic formula. You will get imaginary solutions, and you'll say, not possible. -3 plus or minus the square root of 9 minus 4ac over 2a. Not real. So no critical numbers will come from this, because the denominator is never 0. Imaginary solutions. However, f prime could be 0, which means 2x plus 3 is 0. So f prime of x is 0, which means 2x plus 3 is 0, or x equals -3/2. So -3/2 is the only point I care about. And now I want to study the sign. But I'm not going to waste my time on studying the sign of the denominator because it's always positive. It's never 0. It has a positive leading coefficient. It's a quadratic function, opens up, and it's never 0. So this is always positive. I don't want to waste my time. And this is a linear function with a positive slope. It comes from negative and goes positive. Or you plug in numbers, whatever works for you. Now I have to determine these three values. I have to plug them in. So let's put the function in, please. Okay, it's natural log of x squared plus 3x plus 9. And second in table, and I want -2. I want -1.5, and I want 1. That's all I care about. The first one is 1. Look at that. The first one is 1.9459. The second one is 1.9095. And the last one is 2.56. So therefore, I know that this is the local and absolute min. Obviously, this is the absolute max, and this is nothing. So -2, 1.9459, nothing. -1.5, 1.9095, local and absolute min. And 1, 2.56, because it's at the end of the interval, it cannot be local. It has to be absolute max. Good. Anything else? Anyone, please?
Can we do 7?
Yes, from the same?
Yeah.
Yes, let's look at 7. 5, 4, 5, 6, 7. A graph of a population of yeast cells in a new lab culture. Okay. Describe how the rate of the population increase varies. Okay. At what point is the rate of the population increase the greatest? And so on and so forth. Okay, so let's take it slowly. Maybe I should, what should I do? Maybe I should print out this page. Let me just do that. It will be easier for me to show what I'm doing. And what page was that? 5, 6, 7. It's page 5. Okay, let me print page 5. No, I don't want to print everything. I want to print page 5. Here it is. Okay. So describe how the rate of population increase varies. Okay. So the population starts here, and this is a positive slope, and a bigger positive slope, and a bigger positive slope, and a bigger positive slope, and somewhere around here is the biggest slope, because now it kind of starting to level off, smaller, smaller, smaller. So because the first derivative is always positive, the function is always increasing. And it appears that at 8 is the fastest increase. So f prime is max at x equals 8 hours. So describe. It starts slowly. It increases, increases, increases till the maximum possible for f prime. The highest rate of change is here. And then it starts leveling off, still positive. At what point is the rate of population increase the greatest? We already said that. On what interval is the population function concave upward? Okay, so when what do we know about concavity? So we know that if the second derivative is positive, the function opens up. If the second derivative is negative, the function opens downward. Okay. So this is the graph of function f. So this is given. Since I see that once I'm given the graph, I also know I see that obviously this is opening upward and this is opening downward. So this appears to be the inflection point. So opening upward, opening downward. So I would say on what interval is the population function concave upward? Between 0 and 8. Concave downward between 8 and 18. Estimate the coordinates of the inflection point. We already did. 8, 400. So I would think in these terms definitely when I don't have the graph, but if I have the graph and if I can determine the point of inflection or estimate the coordinates of the inflection point, then I can easily say the function is opening upward and opening downward. So I answered these questions on the side here. Anything else here on this problem? I will scan this too with the rest. Anything else? Other problems, other questions? We want to try anything else?
Number 9.
Number 9. Okay, number 9, number 9, number 9. Okay, perfect. So here we are really asked to do everything. So this is 2x, x minus 2, divided by x squared minus 3x plus 2. And I noticed this. Do not try to simplify anything. Don't touch anything before you state the domain. That would be a terrible mistake to start simplifying before stating the domain. Okay. So here's the table. So please understand, I did see, and that's one of the reasons why I want to see your written work. Again, you have to use a table. I saw someone reverse this order. Excellent. Completely acceptable, great job. So that's fine if that's what you want. I prefer to put the function in the middle, and because I want to read from both top and bottom at the same time, not have to jump over. So that's why I put the function in the middle and first derivative and second derivative. You invented something else, completely acceptable, well done. But you have to use a table. I will not look at your work. I can't even look and see how you came up with the information. You may have just written something. I'm not saying you did, but somebody can just write something and then copy from the graphing calculator. So only if you have the table organized the way you like it, I'm fine. Only then I can say, okay, my student understood everything. He or she knows what she's doing or he's doing. Okay. So at this point, I realized that the function cannot accept 2 or 1. So 0 is here, 1 is here, 2 is here. So only now I can simplify 2x over x minus 1. Since x minus 1 is still left in, x equals 1 must be a VA. Since x equals 2 is gone, or x minus 2 as a factor is gone, x equals 2 is a hole in the graph. At this point, I will plug in 0 and see what happens. I get 0. Can I get any other x-intercept? No, because the top will be 0 only at 0. Okay. At this point, I only need this. And only then I can say I exhausted the function. There is nothing else I can learn from it. Okay. So limit as x approaches negative infinity from 2x over x minus 1. I'll leave 2 outside. I don't care for it. It's a factor. I can always do this. I'm allowed to. It's infinity over infinity using L'Hopital's rule. X approaches negative infinity of 1 over 1, so this is 1. It's the same when x approaches infinity, will still be 1. Y equals 1, horizontal asymptote, both sides. 1, 1, y equals 1, horizontal asymptote. Left and right of 1. Limit as x approaches 1 from the left, from 2x over x minus 1, and limit as x approaches 1 from the right, from 2x over x minus 1. The numerator is definitely positive, and the denominator with 0.9, this will be negative, and with 1.1, this will be positive. So I know negative infinity, positive infinity. Therefore, as already mentioned, x equals 1 is a VA. And now we have to determine the limit as x approaches 2 from the left of 2x over x minus 1, a limit as x approaches 2 from the right from 2x over x minus 1. The top is 4, the bottom is 1, so both limits are 4. I'm going to write 2, 4 holding the graph. Let's stop for a moment and see if you have any questions for me. And I'll take a sip of water. So any questions for me here before we move on? Any questions? It's all clear, everyone? Okay. First derivative. So f prime. Of course, 2 is outside. Weighting is a constant. If I had 2x plus 1, I would have not been able to take the 2 out. But 2 is a factor of the top. So the top prime is 1 times the denominator minus the top times the denominator prime, which is 1, over the denominator squared. And this will equal what will equal is x minus x, which is 0, and then minus 1 times 2, negative 2 over x minus 1 squared. Okay then, nice. It's never 0, always negative, which means that the function must be decreasing at all times. All the time. And now let's see. Now I catch my errors. If these two don't work well together, I know I have an error. From 1 to 0, yes, indeed. From 0 to negative infinity, yes. From infinity to 4, yes. From 4 to 1, yes. It appears everything to be okay. Now I differentiate find the second derivative. And for that reason, I consider f prime as being negative 2, x minus 1 to negative 2. And when I differentiate, 4, x minus 1 to negative 3 times the inner function prime, which is 1. So this is 4 over x minus 1 to the third. It cannot be 0. But to the left-hand side of 1 is negative, and to the right-hand side of 1 is positive. Plug in any number. You will see to the left-hand side of 1, this quantity is negative. To the right-hand side of 1, this quantity will be positive. Which means this. And it's not symmetric. And that's it. And now when I graph it, I will graph the asymptotes first. And it has 2. Y equals 1 and x equals 1. And now the graph. 2, 2, 3, 4. Okay, and 0, 0. So it's coming from 1, crossing at the origin, decreasing all the time, opening down towards negative infinity. That's why I need this. That's why I want the function in the middle to look at this. Otherwise, it will be more difficult to scroll up and down. But I see decreasing, opening down. But it's up to you. Coming from positive infinity, crossing, going through this point, decreasing, opening up at all the time, and going through this hole, approaching 1. So this is the graph of f of x, 2x, x minus 2, over x squared minus 3x plus 2.